Welcome to Maths and Science by IITIan. In this lecture, I will be talking about finding a plus b when natural logarithm of a plus ib is equal to number a plus ib itself. Is it possible? We have to see. If possible, then what are the values of a and b and what will be the value of a plus b? There are two approaches. One is from Euler equations, Euler functions, we can solve the equation, and second is we can solve the equation by using Lambert's equation. Euler's is e to the power of ix is equal to cos x plus I sin x. This Euler equation I have explained in my previous lectures. Please see them for further details. Many examples are solved on this type of questions on complex numbers. And Lambert's equation, that is equal to z is equal to w minus 1 plus 1 minus w, that Lambert's equation z is equal to w of something minus 1 plus 1 or w naught or w1. Now, because I have solved many problems using the Lambert's equation, I want to solve it by Euler equation, this particular problem. There will be many methods in mathematics to solve a problem. I am not restricting anybody to solve in any manner the given problem. I am here in my lectures giving typical problems, exposing the typical problems and solving them in a particular manner. If there are other solutions, other ways of solving, please do it. It's encourageable. In this, I will be solving it in e to the power of ix form solution, and you please try to solve in Lambert's equation form also as a homework. Let's delve into the problem. What is the problem given? Question is, find a plus b if ln, I have told you already it is a natural logarithm, ln a plus ib is equal to a plus ib. If it is not a complex number, it would have been simply e to the power of x is equal to x, or ln x is equal to x. Ln x by x is equal to 1. That also I have discussed in my previous lectures. Please look into it. Now I want to take a complex number natural logarithm equaling it to same complex number, so that we want to find out if there is any solution. If there is any solution, then if there is a solution, find a and b and calculate a plus b. As I told you, there may be many ways to solve it. I am adapting e to the power of ix. In that form, I am adapting this solution. You can do it in Lambert, using Lambert function also. Now, solution. What is ln? Given is ln a plus ib is equal to a plus ib. It is in the form ln x is equal to x. That implies ln x is equal to x. Implies x is equal to e to the power of x. In this form it is there. Hence, ln a plus ib is equal to a plus ib implies a plus ib is equal to e to the power of a plus ib. Then, let us say, take right hand side, e to the power of a plus ib, can we write it as e to the power of a into e to the power of ib? That is equal to e to the power of a into e to the power of ib. What is e to the power of ix? E to the power of ix is equal to, I have written already in the introductory, cos x plus I sin x. These things you should please remember them. Please recollect. Please see my previous videos and understand how these equations have come. Now, e to the power of ib will be cos b plus I sin b. Do you agree? This is Euler's formula. From Euler's formula, which I have explained in detail to you on many occasions. Now, e to the power of a plus ib is equal to e to the power of a into e to the power of ib, that is equal to e to the power of a into, what is e to the power of ib? Cos b plus I sin b. Cos b plus I sin b. Then, what is our solution to be made? A plus ib is equal to e to the power of ib. A plus ib is equal to e to the power of a plus ib, that is what is given, that is nothing but e to the power of a into cos b plus I sin b. Can we expand it? A plus ib is equal to e to the power of a into cos b plus I into e to the power of a into sin b. Now, as per vectors and properties of complex numbers, in the complex plane, we can equate the values of I coefficients, real number, imaginary number coefficients, and real numbers. We have to equate. We will equate this with this. Now, it implies a is equal to e to the power of a into cos b. B is equal to e to the power of a into sin b. Now, a by b is equal to e to the power of a will go off, e to the power of a into cos b divided by e to the power of a into sin b. That implies a by b is equal to cot b. That implies a is equal to b into cot b. Do you agree? but b is equal to e to the power of a into sin b. We will replace this a value in this. B is equal to e to the power of b cot b into sin b. That means everything we got in terms of same value b. Please understand, there is no term a in this. Here b is equal to e to the power of b cot b into sin b, which implies e to the power of b cot b is equal to b by sin b. That means e to the power of some value is equal to some real value. E to the power of some real value is equal to e to the power of some not is equal to some real value. That means e to the power of x is equal to y, where x is equal to b cot b and y is equal to b by sin b. Where b is in radians. Now, e to the power of x is equal to y, it will have many solutions. We will take only principal solution, because whenever you talk about the complex numbers in the complex plane, please remember complex plane if I take a unit circle or any circle for that matter in the complex plane, what happens? This whatever this argument is there, angle theta, this is the angle theta. This is imaginary number, this is real number, and this is x, this is y, this is up to this point it is x, this is o, ox is equal to x, oy is equal to y, let us say. This is point P, OP is equal to Z is equal to x plus IY. This is in a complex plane. This is how a number is represented. A complex number is represented. Now, as theta moves this way, the value of x and y will change, because if theta is here, then the value of x and y will change in the circle. What happens after completion of the one whole circle? That means 2 pi. 2 pi radians is for the whole circle. Again it will repeat. That means there will be infinite solutions. There will be many solutions. For theta, theta can be, theta is equal to, let us say, 45 degrees, then there will be, theta will be 45 degrees plus 2 pi n. Sorry, this 45 degrees you can convert into radians. Take it as a homework. This we can write it as, theta can be varying pi by 4 plus 2 pi n. Please check how pi by 4 has come. Pi is equal to 180 degrees, which implies 45 degrees is equal to pi by 4. Now, that means for n is equal to 1, 2, third circle, fourth circle, fifth circle, you are making more number of what you call rotations in the circle, the more number of theta you will get. First theta will be, principal value will be pi by 4. Second theta will be pi by 4 plus 2 pi. Third theta will be pi by 4 plus 4 pi. That is 2n pi. Like this it goes on. Now, we talk about only one solution, principal solution. That is in complex numbers, we have to define theta. Here I have defined only first value of theta. Then, what is my equation for which I have to find out e to the power of x is equal to y? My equation is e to the power of b cot b is equal to e to the power of b cot b is equal to, what is y? B by sin b, where b is equal to in radians. For what value of b this particular equation will be satisfied? It's a simple equation. Take it as a homework to solve above equation. The answer for b, you adopt any method, there is no problem. The answer for b is 1.33 radians. I am taking only up to 2 digits, the value of b. Then what will be the value of a? A is equal to b cot b. A is equal to b cot b. That is equal to 1.33 radians into cot 1.33 radians. This is equal to 0.31, 0.31. That means A is equal to 0.31 in radians, B is equal to 1.33, which implies A plus B is equal to 1.64 approximately. This is one method. Because this equation e to the power of b cot b is equal to b by sin b, that by trial and error method you can find out very easily. It's not a big problem. Then a plus b is equal to 1.64 radians, and This is using the Euler equation. Now, as a homework, find a plus b using Lambert's function and compare your answer to above. One is Euler method we have seen. Next, Lambert's method. You please do it. The answer should be a plus b is equal to approximately 1.64. With this, I want to conclude this lecture. We have discussed about Euler equation, and from Euler equation we have found out the value of ln a plus ib is equal to a plus ib, means how to solve it and what is the value of a plus b. Now Lambert's equation function also we have discussed. Please try to do your get a solution using Lambert's function and compare with this value. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture. If there is a value addition to you because of this lecture, please share and subscribe to my channel Maths and Science by IITian.